Welcome to another marvelous edition of Comet Algebra. This video is for Algebra 1, Chapter 9, Section 1, Classifying and Evaluating Polynomials. So we're advancing our algebra skills here in this chapter, learning to work with a little more complex algebraic expressions. So we got some terms to learn. So let's start with an old term, reviewing. And the old term we're going to review is the word term. How's that for redundant? Terms in an algebraic expression are connected. They're glued together by multiplying and dividing, and they are separated by adding and subtracting. So you can add that here to your notes if you'd like. This expression we have in this example has 4 terms. This is one term because the 4 and the x cubed are connected by multiply. This is another term connected by multiply again, and notice separated by the adding sign. This is a term connected by division, separated by the multiply sign, and of course 89 is a term in and of itself, separated by this adding sign. So this expression has 4 terms, and it is a polynomial. The word polynomial is a very general term, word. It's used to say that it's an expression that can be written as adding and subtracting a bunch of terms which have positive exponents. So there's a few things that we'd have to say are not polynomials. And you'll be asked this in your assignment. Something is not a polynomial if it has negative exponents, or if you have a variable in the denominator, if you're dividing by a variable, because by definition that would be a negative exponent that got flipped down. So we'll look at some more examples of that in a moment. This example, this polynomial has 5 terms. There's 1, 2, 3, 4, and 5. And you'll notice in this expression there's no negative exponents. We're not dividing by any variables, so this is indeed a polynomial. We now have a few more vocabulary words to learn. A monomial is a polynomial with just one term, mono meaning one. A binomial, of course, has 2 terms, bi like a bicycle with 2 wheels, bi means 2. Trinomial, like a tricycle with 3 wheels, a trinomial has 3 terms. They're separated all by adding and subtracting signs. A polynomial also has a degree. The degree of a polynomial is the highest exponent, and this is going to come in handy later when we're solving these, and the degree is going to tell us how many answers we're looking for. In this example, what is the degree of this polynomial? Well, since the highest exponent is a 3, this is a 3rd degree polynomial. Another thing to discuss is putting polynomials in standard form. And this is pretty straightforward when there's one variable, but it gets a little more tricky when there's more than one, and we'll discuss that. But in standard form, you put the term with the highest exponent first, and then the second highest, and so on. And what I'll call this, if I can spell it, I'm not sure. We call this descending powers. You'll have to let me know if that's even close to being spelled right. Descending powers means the highest one first, and then the second highest, and so on. In our example, if we're to change this to standard form, we just kind of scan through and look at the exponents, and of course this one has an x cubed in it, so it's the highest, and then the x squared term, and then the x to the first term, and really this 10 does have an x to the 0 power in it, because x to the 0 is 1. Now, when you have 2 letters in polynomial, the letter that comes first in the alphabet sort of wins. And so if you have an xy type of a polynomial, you would look at the powers in the x and descend from there. And you can ask some examples if that gets confusing. So the first skill we need to have is to be able to classify the polynomial by 2 things: by the number of its terms, meaning a monomial, binomial, trinomial, or polynomial. Poly means many, so anything that's more than 3 is just polynomial. And we need to classify it by its degree. So this first example, of course, the highest exponent is a 2, so we would say it's a 2nd degree. And since there's two terms, this is a binomial. So it's a second degree binomial. Number two, the highest exponent is a 3, so we'd call this a third degree. And this one happens to have three terms, so it is called a trinomial. And example number 3, all of these letters have an exponent of 1. So this is just a first degree. And of course, it's just one term because it's all connected by multiplying. So this is called a monomial. Now we look at number 4, and you might want to say that this is a second degree binomial, but it's not. Look a little closer. This is a problem. This c squared is down in the denominator. So if we were to flip it up, can you picture that this would look like if you flipped this back up to the numerator, the exponent would be negative. And so this is breaking the definition of polynomial. So all we say here is this is not a polynomial. So your work ends there. The other thing you'll be asked to do in your assignment is to evaluate polynomials given certain values for the variables. Now, if you recall, the word evaluate has a root word of value. So what we're doing is finding a numerical answer. You're finding the answer when you plug in these values for the variables. So keep the 2. Where you see the x, put in the -1. And where you see the y, put in the 6. And if you multiply these, I believe the answer is -12. Example number 6, again, plug in the -1 for the x, plug in the 6 for the y, and plug in the -5 for the z. And then, of course, follow PEMDAS, do the squaring first, and then the multiplying. So then I'd end up with -1 plus, and 36 times 4 is 144. -8 times -5 is +40. And then if you add these up, if I added correctly, I got 183 for this value. All right, now this last one, again, for the x, plug in a -1, square it, times y is 6, minus, be careful to put your -1 in parentheses so you don't lose track of any of these negative signs, plus 3 times -5. Okay, so evaluating this, when you square a -1, you get a +1 times 6 is 6. Here, doing the squaring first, 36 times -1 is -36, but then we have this minus sign, making it a +36. And 3 times -5 is -15. And when you add these up, I got 27. All right, so now you have the knowledge you need to do section 9.1. So have fun with math.